Hey everybody, I'm Taylor. Thanks so much for the introduction, Paul. And today we're going to talk about JavaScript's performance in extreme environments through the lens of our production web app for refugee aid groups. So start off with some background on the aid movement, look at those extreme environments. Setting performance goals is always a great place to start when diving into this stuff and outlining a strategy, and then look at the tools and techniques we use to improve performance in our own app. This is my first ever tech talk, both as an attendee and a speaker, so I really, thank you. And I just want to emphasize, I'm nothing special. I'm just like an average web dev. I needed to do this to make our stuff work in the field. But the takeaway from that is that you can do this too. You don't have to be an expert. It's not using some really advanced API or anything. So hopefully on Monday you can go in, take a look at some performance in your own apps, maybe do some improvements. Who knows? Cool. So the Refugee Aid Movement. It's one of the largest grassroots, volunteer-driven things in the world. It has had tens of thousands of volunteers working with hundreds of grassroots aid groups, welcome millions of newcomers to Europe. It's kind of this interesting network of distributed autonomous groups. They each do their own part independently, which means they can respond really quickly to changing conditions or new needs that governments or larger multinational NGOs can't. But there's lots of communication overhead and lots of inefficiencies around these administrative processes. So it's a diverse movement. It's led by women. You can see our board there. On the left is Stephanie, who's a admin at Movement on the Ground. We'll be talking about some of their work on the island of Lesbos later. In the middle is our own director, Sarah. Say hi if you see her around the conference. And on the right is Rudina, who has started an aid group that takes donated laptops and equipment, loads educational content on them, and sends them to informal schools in camps. So I think it's really cool to see women at the forefront of this movement. This is something that's not going to be solved within our lifetimes. There's 70 million displaced people in the world today. 20 million of them are refugees in another country. And due to climate change, we're looking at up to 1 billion displaced people in the world by 2050. So this is something that we need to pay attention to now. We need to build the infrastructure for now. And I'm really grateful to indigenous people all over the world and our youth like Greta, who are fighting to reduce the impact of climate change. A little overview of our tech. We have three main areas of our platform. There's kind of discovery and networking. There's the aid supply chain, so tools around getting things from A to B. And there's the knowledge sharing section to help share knowledge, things like that. So our goal is to increase collaboration, save time, and help groups make smarter, better decisions, really by just surfacing more information in a centralized place in an easy to consume and structured way. But the important thing is that our tech empowers groups, which means if they can't use it, if it doesn't work where they're at, then what are we doing, right? We're free as in freedom and beer. Best of both worlds, right? We're using the AGPL, and we're a nonprofit, so it's free for aid groups. And this is going to be important when we talk about testing strategies and stuff. I'm the only full-time dev on our team. We have a great team of remote volunteers. So we need to approach kind of performance testing through the lens of a scrappy, volunteer-driven nonprofit, not through like $1 million lab or something that you can just have a bunch of boxes like automate all of this away. Cool, just a couple of slides here about our tech. That's the profile. This is the aid marketplace, the inventory manager, where you can see what's available and what people need. And then we have the shipment coordinator, helps you keep track of decisions that you make, where things are going. And this is great because it shows you, hey, the town next door is sending a shipment. I can just throw some stuff on there and they can include it rather than sending another one myself. Cool. So the impact in the real world, we coordinated a shipment of 180,000 bars of soap from Glasgow to Caring City in Scotland. It went to central warehouses in Athens and Thessaloniki, and they distributed it to dozens of aid groups all over Greece, including the islands. And most importantly, the end result, we get this to the people who need it most. So that was kind of the intro section. I'm glad I'm doing well on time. And now we're going to take a look at some of the extreme environments that our users operate in. Okay, maybe not that extreme. So this is Moria. It's the largest refugee camp in Europe. It's on the remote Greek island of Lesbos, right next to the Turkish border. It's a former prison designed to hold 2,000 inmates, and that's the kind of prison section right there. There are currently 10,000 newcomers living in the Moria refugee camp, and you can see the massive overflow area and kind of an informal camp in the foregrounds there. And that's called the Olive Grove. So this is the kind of border outside Moria, surrounded by barbed wire. And this is what you see every day as an aid worker. You're going into camp, you're doing all sorts of things to help people out, 10 to 12 hours a day. It's like an all-day thing. You don't get a lot of time to rest, relax. You don't get a lot of time to go back to the office and jump on the Wi-Fi or charge your phone up. As you can see, there's not really any power infrastructure there. The cell signal is spotty. So we have to take all of this into account when we're trying to figure out how to make our app work for the aid workers. So we don't operate here, but there is a little bit of interesting other extreme environments. You have search and rescue ships at sea who are on the ocean for months at a time. And you have human rights observers who are on borders. This is a photo of the Hungarian-Serbian border, which has 500 kilometers of razor wire. And so the human rights observers are going to be out in remote parts of the country, remote villages, kind of monitoring for things like border pushbacks, stuff like that. And last but not least, my favorite place, which is warehouses. So this is really cool. That warehouse was actually the old 2003 Olympic basketball stadium in Greece. Just a ton of fun to walk around and explore. And aid groups really, they just popped up overnight. They asked the government, hey, can we have some space? And they have to work with what they're given. So it's not something where they can design a connected infrastructure, set up the Wi-Fi through the whole thing. It's like, here's a shed in my backyard. Here's a converted basketball stadium. Make it work. So the storage space there is in the ring in kind of that concessions area, outside of the main stadium. And that's what it looks like inside there. So they have cell service, don't have Wi-Fi. They do have power, but again, people are dealing with inventory and stuff all day, every day. So let's actually take a look at what we mean when we're talking about performance. High-speed situations. This is Amsterdam. This is the office in San Francisco. Low speed might be my own office in Serbia. Gets the job done. Sometimes the video calls are a bit flaky, but it's okay. No speed, there are lots of situations. We talked about some of them, like at sea, on the borders. And then we have this fun one I like to call maybe speed. So this is really warehouses, this is camps. You might have some cell signal, you might have some intermittent Wi-Fi, there will be dead zones, and that produces a lot of problems. It's not just online, offline, online, it's ping-ponging you back and forth. So you have random latency spikes. Race conditions are a huge issue. And from a UI standpoint, you have to deal with this back and forth between the different states. You don't want to just be showing up the pop-up, you're online, you're offline, you're online, in very rapid succession. So when we're talking about speed, we're really talking about latency, bandwidth, and throughput. That's an example of a warehouse. So that's the office with the Wi-Fi there. This is about the size of a football field. As you can see, that Wi-Fi is not going to extend throughout the whole place. It's kind of like a giant Faraday cage. And then this is a fun one. So to get Wi-Fi in the Olive Grove, which is that overflow area outside of Moria, This is the town of Mitteliti. It's the largest town in the island. They have a satellite dish or something that sends it to a water tower. Another satellite dish there bounces it off to the camp. That's about 4 kilometers right there, just beaming that off a water tower. It goes into a satellite dish on the office there, and then they have a series of Wi-Fi repeaters around the camp. So clearly dealing with super high latency there, intermittent connectivity, a storm or something can just knock out that infrastructure. There's the office right there, and that's an example of a telephone pole with one of the Wi-Fi routers or the repeaters on it. So something else we need to consider is data and power. So you have unmetered Wi-Fi, you have mobile data, or you just don't have data. Same thing with power, plugged into the wall, you're on the go, or your device is dead. And these are all resources that our users have. In our context, they're very limited. If you're out and about using your phone, using our app all day long, we can't kill that battery, right? You have a certain amount of time, and then your phone's dead, and then you're back to the old pen and paper way. Same thing with data. It's nice when you have an unlimited plan. Most aid workers that I know, they might buy 1 or 2 gigabytes at a time. So they're constantly running out of data, having to wait a day, go back to the cell phone store, plug some more data in. And if your stuff just stops working when they run out of data, again, back to the old pen and paper way, it's a bug, it's my problem, they're not gonna make it their problem. And then we have hardware, so lots of old donated equipment. I'm gonna speed up a little bit to make sure I stay on time. But this is an example of my friend's computer. It just doesn't have a battery, right? She just leaves it plugged into the wall. If there's a gentle breeze that knocks the cable out, then she immediately, loses all her state of what she's been working on. This is my friend's phone, different friend. He can't use about half his screen. So I think that's maybe a different tech talk, how to make your app work with a busted phone. But that's the type of equipment that we're dealing with here. This is all more relevant than you might think, right? So a slow connection is a slow connection. Warehouses have dead zones. Offices have dead zones. There's some poor guy in the basement, trying to just get the printer to work, and he has to run up and down the stairs every time he wants to print something to connect to the Wi-Fi. If you don't have a connection, you don't have a connection. It doesn't matter if you're in the middle of a refugee camp or if you're on a 6-hour plane to come talk, at JSConf Budapest. A dead battery is a dead battery, regardless of how fancy your phone is. And old hardware exists in many real-world businesses. Hospitals are a great example where, due to budget or regulations, they're running sometimes Internet Explorer in 2019, right? So let's take a look at some performance goals. And you want to start here. Really important when you have these conversations with your managers. Everyone, the marketing department, the DevOps people, they want their stuff included in that page load. And so you need to be realistic and set those goals, which will then help you prioritize what's necessary, what can you cut, what can you delay. So in our case, we're looking at a mid-range Android device on, we're going to say, a bad 3G connection. 400 kilobytes a second bandwidth and 400 milliseconds latency. We want to minimize data and power usage. And we're going to focus for speed on 2 key indicators. There's time to first paint and time to interactive. So we want, on an initial load, less than 2 seconds to first paint, and subsequent loads less than 1 second. And for interactivity, we want less than 5 seconds on an initial load and less than 2 seconds after that. And remember that latency here is the killer. So that's going to take up, easily 20 to 40% just pinging the server for a round trip. We have product goals. Hopefully we're building stuff to do useful things, whether that's relax and have fun or make something that people want to use. In our case, we try to support modern browsers on desktop and mobile. We're not supporting Internet Explorer. and we need it to work offline. So it's okay. We can cut some content and functionality, like our maps page. We need to get tiles from a server. If you're offline, we're just going to say, don't use the maps, wait until you connect. But there's lots of other stuff that does need to work. And I think that, yeah. Right, okay. So business goals, no ultimatums. I think that performance is something you should take an incremental approach to. Make one performance change at a time. Something is better than nothing. Build in offline support one step at a time, starting with the most used or most impactful workflows. In our case, we need reasonable testing overhead. Like I said, it's a volunteer team. So we have to kind of keep that in mind. We're not going to have a budget for extra devices or a lab, and we need to balance this sort of performance testing with new feature development adding on there. And I think that one of the best things you can do is if you're talking to your users, talk to them about performance, right? It's you have your product and application bugs and stuff like that, but tell them, listen, if it takes too long to load and that makes you frustrated, that's a bug. Like, talk to me, tell me about that. I want to know what device you're using, what the connection was like. Go to speedtest.net and send me a copy of the results so that I can have realistic benchmarks when we're doing our internal testing. I think that we have lots of great conversations with users. We should definitely extend that to performance. So I'm going to dive in here and look at our strategy to make these improvements, look at the tools that we're using, and look at the techniques and results that we had in our production application. Sweet. So our stack, I can hear the groans already. Yes, we're using jQuery in production in 2019. I think 2009 called and they want their developer back. It's pretty modern on the back end. We have Elixir and Phonics sitting behind an Nginx proxy. We used Webback, of course, to kind of bundle up all of our front-end assets. The reason for jQuery is that I love the data tables plugin. And when you're prototyping, none of this matters, right? We're going to be cutting that out and probably go with no framework on the front end. But this is good. In this case, raise your hand if you're building a single-page application. Vue, React, it's a lot of hands. So we're not. I'm going to have some stuff that touches on performance considerations with single-page applications. But just in terms of the numbers I'm showing on screen, jQuery is kind of halfway between Vue and React in terms of like library size. So some realistic numbers there. So let's look at power usage. What's really going to drain that device battery? It's going to be two things. It's going to be the antenna, and it's going to be running that CPU or on the laptop, the GPU, and stuff like that. So how to minimize antenna is just minimizing networking, right? Batch requests. If you're sending telemetry or something, if you could batch those, collect all the data every 50 milliseconds or whatever you want, but only send it up to the server once a second, or once every 10 seconds, or on the next load. We don't want to use polling because that's going to send a heartbeat out. So there's some great tech out there like WebSockets, which do a much better job of keeping a TCP connection open without that heartbeat. We want to limit animations as much as possible. Every time that you have an animation going, it's going to be repainting on the browser, running that CPU. And I'll show you some performance stats on that in just a minute. Syncing timers is important as well. If you have like 10 different timers going off that aren't synchronized, that's going to wake the CPU up every time. If you have something that, 50 millisecond interval, and then every third time it goes off, you run some other function and synchronize it that way. It's a much better strategy. And for common events like the scroll event or whenever a user types on the keyboard, things that are going to fire a lot like that, you want to use timeouts and just kind of take samples of them rather than responding to every single one. So we're using the Chrome DevTools. This is the network panel. This is Google's homepage, and every time you type in a character, it makes another network request. So this is what I'm talking about with those events, with that networking. This is going to keep the antenna on your phone on that whole time. It's okay. I think when you're looking at really optimizing performance, this is great on a desktop, but it's fine to just let the user type in their search query and hit the search button and make a single request up, or to do it once a second or once every half second. This is, I've loaded up some page with like a spinning loading animation on there, and this is what it looks like using Chrome's DevTools performance panel. You can see all of that activity, all of that repainting constantly, which is going to run that CPU and drain that battery. So another strategy is minimizing data usage. This is just small bundles is really the answer, and aggressive caching. You want to compress your payloads. You need to cache everything you can. Load content as needed, which means if you don't need it up front, just grab it in the background. If it's not on that above the fold, then load it as the user scrolls down, if they scroll down, because oftentimes they're just going to click a link on the main menu and they never need that second half of the page. And then I think for pre-caching, with a service worker or something like that, you want to get your app working offline, ask for consent. Just a simple button like, hey, would you like to download the offline experience? I think it's important when you're looking at people with low data, like they're on a limited metered plan, to just give them a heads up. It's the polite thing to do. And then improving speed, a lot of the same thing. You need to compress payloads, cache aggressively. Server-side rendering is super useful here. That's really going to reduce the amount of time it takes to get to that first paint, which means if you're building a single-page application, you do need to do a little bit of extra work and actually send down some HTML. At least send down an application shell. Send down the header and the footer and a sidebar and maybe a little loading message or something to just get something on the screen. And then once your JavaScript loads and pulls in the rest of the content and compiles the templates, it'll fill out the rest of the experience. Sweet. So images are going to delay interactivity. It'll show useful stuff on the browser right away, but it's not going to run the JavaScript until after the images are loading, so we try to delay that as much as possible. There's also, in limited bandwidth situations, you can be pulling multiple things from the network at the same time, but if your pipes are really small, like trying to send it to the refugee camp, then you don't want your JavaScript download to be competing with a bunch of user-uploaded images. And minimizing the amount of stuff on the critical path is definitely a good technique, especially for single-page applications. You don't need all of your templates at once. Load the current template, load the interactivity above the fold, and then asynchronously grab the rest of that once the page is up and running. So we're going to be taking a look now at our groups list page. This has static content, static sections of the site, user uploaded text and images, and some JavaScript functionality. You can sort the table by name, you can do a search. And we're using really, for tools, like keeping it simple for our team is Chrome DevTools, network, and performance panels. There is some setup here. So to simulate a bad 3G connection, we're slowing down the CPU as much as DevTools will allow. And we're putting in a custom network throttling profile. So remember, it's 400 milliseconds latency and a 400 kilobyte a second connection. And we're going to take a look at a baseline. This was our app 2 weeks ago. We already do have some goodies. So because we're doing a server-side rendering model with Phonics and Elixir, that's there. Webpack already does some minimization for us. And Phonics has built in cache busting. Raise your hand if you know what cache busting is. OK, 50-50. So basically, what you do, you compile your assets and generate a hash of the file, and you're actually going to serve up a file with like, app dash the hash.js. What this means is that you can send your caching headers, right? Just tell the browser to hold on to that forever. They never need to load it again from your server as long as they have a local copy. When you make a change in your application, it generates a new hash, and you actually just download a different file, which is, I think, a pretty good way of dealing with caching and just trying to hold on to that data as long as it's needed. So, yikes. This is our initial load time. It took 5 seconds on our simulated connection to paint the page. It took 22 seconds to become interactive, and we downloaded basically a megabyte of content. This seems really bad. It is a bad 3G connection. In 2017, this was the average load time for mobile. It was 22 seconds to just grab a page. So I think we can do better than that. This is the performance pane in DevTools. You see really long load times, grabbing that JavaScript file to get to interactivity, even just grabbing the images and the HTML took quite a while. So secondary loads are better. We can take advantage of browser caching. Takes about a second to paint the page and become interactive. And because we're using cache busting, we're just grabbing the updated content. So it's just the HTML file. This might be something with a single page application. It's cached all your JavaScript, and you just have to make a JSON request or something like that. So you can see there it's loading just about everything from hash except for the HTML page. So we're going to focus on some speed improvements here. I thought that we had gzip going. It turns out I got a configuration file wrong, and we didn't at all. So I did some research, and I threw on Brotli. It's basically the new gzip. It has about a 25% smaller file sizes when the compression's done. I added HTTP2 to Nginx, which multiplex requests. It can reuse TCP connections, which means you don't have to deal with that latency for every single pipe that you have open. You just open up a handful of them at the start, and then you can load up more stuff through those pipes. I implemented a fairly simple bundle splitting strategy in Webpack. So I think that we could do even more here, but for now, I just wanted to separate our application code and styles from our vendor code and styles, because the libraries and stuff we use don't change nearly as often as updates to our actual business logic and front-end code. This will allow me to cache that vendor file and just keep it there for weeks at a time until we throw in a new import while we're making daily changes to the application. Yeah, some image resizing, just cutting down. Take a look, like you're throwing on Font Awesome or something, you don't need 1,000 icons. You're probably just using 50 in your app. Double check that. And lazy load user-generated images. You can grab them after you get interactivity. So we hit our goals. With these improvements alone, we got it down to just under 2 seconds to first paint, 4.5 seconds to interactive, and really cut down on the amount of data we're transferring and the overall size there. So just with some simple improvements, a couple of server configurations, lazy loading the images, and doing some bundle splitting with Webpack, we see over 60% performance improvement in the metrics that matter. You can see here that that side, that's those images that we're lazy loading. So the paint happens really quickly. We're reusing a lot of the same TCP connections with HTTP2. It gets to interactivity, and then we just grab the rest of that user content. Subsequent loads, similar sorts of improvement. We're down to under a second on a bad connection for first paint and interactivity, and we're only serving up 2.6 kilobytes, just the updated content on the page. So I got 1 minute, and I'm just going to touch on service workers really quickly here. Our basic strategy, we want to cache all the static assets on install. and serve them with a cache-first approach. So this is where cache busting comes in really useful, is that if you have that file there, just serve it up. No need to go to the network. If you don't, then fall back to the network, grab it, cache it for next time. And then for the pages, because those might be updated with user-generated content, we want to do a network-first approach, but keep them cached. So grab them from the network, grab the latest copy. If you go offline, be able to serve that copy from your cache. So we're using service workers, we're using the cache API. Yeah, and it gets really fast. So this is with online. We have half a second to interactivity, and most of that is a 400 millisecond latency to grab the updated HTML page. And that's what we see here. So it's just grabbing that stuff and then loading everything from cache. What's really interesting is that offline is actually the best performance. Because we don't have that latency, we don't have to hit the network up. It just loads the last version of everything we cached, 100 milliseconds to get there, 150, no database transferred. So once we kind of wrap this up, make a couple more touch-ups to our service workers, I'm just going to tell aid workers in the field, hit airplane mode. Like, download the latest copy in the morning, hit airplane mode, do your work all day, unhit airplane mode, and upload it at the end of the day. Cool. So thank you so much. That's kind of my talk. I hope it served as like a good overview of performance optimizations you can make in JavaScript and a little bit about the Refugee Aid Movement. You can check out the offline functionality on our app. All the code is publicly available on GitHub, and I'll be throwing the slides up along with some links to further research and tutorials on our Twitter. Cool. Enjoy your lunch.